is on segments and their measures. So the ruler postulate, very easy. Guys, you with me? So since every point on a line can be paired with a real number. So we could have a number line, and we could have like A is at -2, Z is at 1, B is at 2. The distance between two things, like if I talk about the distance between Z and B, it would be 1 unit, right? 2 minus 1. The distance between A and B would be 2 minus a -2 in absolute values. So what do I do when I do 2 minus a -2? I get 4 in absolute values. Could I have done it the other way? Could I do -2 minus 2 and take the absolute values? Do I still get 4? Yeah, so that's what the ruler postulate says. A distance involves the absolute value because distances are always positive and absolute values are always positive. So if I have something like 5 minus 3.5, it's 1.5. In absolute value, still 1.5. Right, so here we go. So like 3.1. And this next one, what's our answer? -3, but then absolute values, so it's 3. So it says measure the length of the segments to the nearest unit given. So it's saying measure this in inches. So that's a little tricky. I didn't make it nice. I didn't try to make it exactly like 2 inches, so we have to use fractions. So use your ruler and put it up against your notes, and we shall see what it is.
I got 3 inches exactly.
3 inches exactly? Ooh,
Yeah.
I don't know. Did you guys all get
2.9.
almost 3 inches? I would say like 2 point, what are these tick marks? What are they in? 1, 2, 3, 4, 5, 6, 7, 8. There's 16. So if it went one more space, it would have been at 3, but it's 1 space away, right? And if these are 16ths, then that means it's going to be 2 and 15/16 of an inch. You would not think that 15/16 is important, but it is. So simple things, like I was buying a new plug for my son's piggy bank because he freaking lost the plug and all of the money kept falling out of his piggy bank. So I was like, Amazon, do you have piggy bank plugs? Like, that matters because they have some that are 1 7/8 or 2 inches. Like, I need to know the difference between those. So measuring is important, right? We don't want to measure things and be incorrect. Have you guys heard the thing that carpenters always say? Have you heard the saying?
Measure twice, cut once.
Measure twice, cut once. That's right. All right, so millimeters. So now we're going to use the other side of the ruler. We flip it around. And centimeters, oh, this one's perfect, isn't it? It looks like it's perfectly at 3 centimeters, but that's not millimeters. What do I write for millimeters?
30.
Yeah, it's 3 centimeters, which is the same as 30 millimeters. So 30 millimeters is what we want. And then centimeters, same idea, so put your ruler on there. So we're going to use fractions again.
150.
It looks like it's a little bit more than 4. And now these ones are in tens, right? So it's 4 point, what do we think? 4.3? Yeah, I agree with that. Let's say 4.3 centimeters. So what would that be as millimeters? 43 millimeters. Perfect, good. All right, the segment addition postulate. It's very easy. So it basically says if this is 3 inches and this is 1 inch, what's the total length then? 4, right? We just add those together. So the way we write it with geometry is we say A, B, yeah.
I have questions. Like when we're measuring, do we include the end?
I know, I really shouldn't have done those little dots, should I? What I did is I went from the center of the dot. So I went from right there in the center to the center of the dot.
Okay.
Maybe I should do the ends as like little lines. That would make that easier, wouldn't it? All right, so segment addition postulate says that if I have the length AB added to the length BC, it equals AC. Now, notice it's talking about segments. I didn't put a little line segment over it. That's because when I talk about a distance, I don't put the segment over it. So if I talk about the object, like segment AB, you guys remember how I write that as AB with a line over it? But if I talk about the length of AB, I just write it as AB. Okay, and I'll talk about that a lot throughout geometry. So no lines over these ones. All right, so 2 friends leave their homes and walk in a straight line towards the other's house. When they meet, one has walked 578 feet, and the other has walked 498 feet. How far apart are the two homes? So what do we do to get that?
Add them together.
We add them together. Now think about our mental math skills. So often you guys are so quick to pull out a calculator. All right, if I have 498, how many more do I need to get to 500?
2.
2 more. So I'm going to take 2 away from 578. So I really have 576 added to 500. Can we do that without a calculator? 1,076. Units?
Feet.
Feet. That is correct. Yeah, Ian?
Well, you have to add, like, oh wait. Oh.
Oh, I regrouped, as we call it. So I had 578 added to 498. And instead of doing that on my calculator, I just kind of regrouped some things. All right, so AC, this whole distance from A all the way to C is 55.6. It says find A, B, and BC. So how can I write an equation using that 55.6? Anybody have any guesses? Tell me the equation. What do you think, Keegan?
You can do like 55.6 is equal to like 3x plus 1 plus 5x.
3x plus 1 equals 5x minus 3, and that's all equal to 55.6. All right, so I'm going to solve the equation. I'm going to add my 3x and my 5x, so I get 8x minus 2 equals 55.6. So I get 57.6. And now I'll let you use a calculator. So take your 57.6 and divide by 8. What do we get? 7.2. Did you guys all get 7.2? Okay, now be careful because the SAT does this a lot. So we found x equals, and that's when people would like bubble in. They'd be like, oh, 7.2, that's my answer. What does it ask for?
Find A, B.
Yeah, so we need to do the second part of the problem. So I need to find AB and I need to find BC. So AB is 3 times 7.2 plus 1. So I'm going to multiply by 3 and add 1. So it's 22.6. That's a plus there. And then BC is 5 times 7.2 minus 3. Now I could also get that by taking 22.6 and subtracting from 55.6, right? So either way, you should get 33. All right, still feeling pretty good about segment addition postulate? Easy, right? We got this. All right, let's try some harder ones. So it says AB is 3x minus 5. CD is 6x minus 18. AD all the way down is 27. Do you guys like drawing these things? Everybody always hates drawing those. It's called a brace. Can we draw a brace? If you can't draw a brace, you could draw it in another way. You could draw it like this. So you could say A to D is 27, like that. Either way. Okay, but it also says BC is half of CD. So half of CD. So how can I represent half of CD?
3x.
Yeah, 3x minus 9. Do you guys see that? So that's going to be the 3x minus 9 because we did half of the 6x minus 18. So now we need to create an equation. Well, we can say, oh, segment AB added to segment BC added to segment CD has to be the total length of AD, right? So we're going to write that out. We're going to say 3x minus 5 added to 3x minus 9 added to 6x minus 18 has to equal the total length of 27. Now we start combining. So we get 12x. We had minus 14, minus another 18, so minus 32 equals 27. We add over, we get 59. Oh, I could have easily made this so much nicer if I just would have made that 60, but you know, sometimes math isn't nice. Sometimes we don't get nice numbers. So we get x equals the lovely 59 over 12. That is our answer. It does not reduce. All right, find the indicated length using the segment addition postulate. So these ones aren't too bad. These are all just numbers. We like numbers. So I want you to look for pieces where you're just missing one part. So like see how we have 16 here and we have 30 here? Does that allow us to find a missing part?
Yeah.
If we had 16 and we had 30?
14.
Yeah, this should be 14, right? Does that make sense? So we're thinking of it like that. So now if we have 14 and we have 16, well, that's the 30 like we wanted. What does this part have to be, the ED? 49 minus 30, which is 19. So our E to C ends up being 19 plus 16, which is 35. Okay, so you guys try the next one. So what do you guys get for KL? 19, 19, because 31, not 30. All right, so now 31 subtracted from 49 gives me the IJ, right? What's that? Oh, that's the 18. That's where you got that. So if I want I to K, is that what that says, IK? Yeah. IK is going to be 18 added to 12, which is 30. Okay, does that make sense with just the numbers? So now we're going to get a little bit trickier because now we're not just going to have numbers, we're going to have variables too. But we're going to use that same concept, what we just did. So to find certain pieces, we subtracted out other segments, right? Or added. So in this case, well, I guess we're good here. So we can just say, what's our equation? So we're going to add up 3x minus 28 to 3x minus 30 to x, and that has to all add up to be what?
33.
Yeah, 33. So we have our equation. So we have 3x minus 28 added to 3x minus 30 added to x has to equal 33. So we end up getting 7x minus 58 equals 33. So 7x equals 91. Did you guys know 7 goes into 91? 91 is not prime. How many times does it go in? 13, yeah, 13 times. So x is 13. Now again, be careful because that's not what we asked for. We asked for DE, right? So now we find the second part of the problem. We're like, oh, well, DE is going to be 3 times, let me move this. It's going to be 3 times 13 minus 28. So 39 minus 28 is 11. That's what DE is. So one thing at a time. Okay, here's the tricky one. Are we ready? Okay, what do we think? Who can come up with an equation and tell me how they came up with the equation? My hint is if you can come up with what this is or what this is using x's, you'll be good to go. Brett, you look like you want to say something. Yeah, go for it.
We're doing D, right?
Uh-huh.
So I just added 2 to both 2x minus 4 and 2x minus 3. And then I did, so 2x, it would be then 2x minus 2 plus 2x minus 1 equals 3x minus 1.
Ah, he's so close. So he said he added 2 to both pieces. Okay, but let's think about it. Let's think about if it was a number. What if this had been 20 and this part was 2? What would this part be? It'd be 18. So what do we need to do to both sides? Subtract 2. Perfect. All right, so we were really close. So we're going to take this 2x minus 4, and this is going to be 2x minus 4 minus that 2, right? Because when I add the 2 to it, 2x minus 4 minus 2, added to 2, those 2's will go away, and we're left with this 2x minus 4, right? Does that make sense? Do you guys see what I'm saying? So that's going to be 2x minus 6. And then this side was our 2x minus 3 minus that 2, so it's going to be 2x minus 5. So creating our entire equation, we have 2x minus 6 added to 2 added to 2x minus 5 has to be 3x minus 1. Okay, so let's write that equation. So 2x minus 6 added to 2 added to 2x minus 5 has to equal 3x minus 1. Now I didn't have to find both of those things. I didn't have to find both 2x minus 6 and 2x minus 5. Because see how I could have just done like the 2x minus 4 added to the 2x minus 5 and I'd be good. So you don't have to go too far if you want to. So we get 4x minus 9 equals 3x minus 1. So x is equal to 8. So then it says find the distance from B to D. So find BD. So we're going to do 2 times 8 minus 4. So 16 minus 4. So we get 12. Yeah, it's a tricky one. That's as hard as I get. If you can handle that one, you can do every single one. All right, is that the last one? All right, so congruent segments. So I'm going to flip the page. Are you guys good? Do you guys have all that? Okay. So congruent segments. So segments that have the same length are called congruent. Have you guys heard that word before? Congruent. It means they're the same length, okay? Segments are congruent, but lengths are equal to each other. So if I talk about congruent segments, I would say that EF and HG with the line segment over them are congruent. So objects are congruent. But if I talk about their lengths, then I would do EF without a line over it. And I'd say it's equal to HG. So lengths are equal. Okay, so it's kind of a tiny thing, but it's a big deal in geometry because eventually we're going to do proofs and we want to be as precise as possible. So when we talk about objects, like a segment and a segment, or an angle and an angle, I'm going to say they're congruent to each other. But when I talk about their lengths, and when I don't have that little line over it, I'm going to say they're equal. And with angles, I would say like angle A is congruent to angle B. Sorry, that got a little messy. But I would say measure of angle A is equal to the measure of angle B. Like their numbers are equal to each other. Okay? Kind of a slim, kind of weird. All right, so midpoint. So a point that divides a segment into two congruent segments. Okay? A segment bisector. Every single geometry test has a vocab section, by the way. So you should know these. So pay attention. So don't just be like, oh, I'm not going to pay attention. She's just reading definitions. Right? You have to do all this. All right, so a segment bisector is a point line, ray, or segment that divides a segment into two congruent segments. So the midpoint would be like point M. It's a point, hence midpoint. But anything that meets at that midpoint, like this is talking about line K, that's a segment bisector. So anything that is having it, and it's breaking it into those two equal pieces. Okay, so notice how we're using these little tick marks. Do you guys see these little marks on our segments up here? That means that they're the same length. So if I have this little mark here and a little mark here, that means they're the same. What if I had two marks and only one mark on the other? Then they're not the same. I mean, they could be the same, but they're not necessarily the same. Okay, so they have to have the same type of mark. So if I had a diagram where I had like a mark here, and then I had two marks there, do you guys see which ones would have to be equal? It doesn't necessarily mean it's longer. It just means it's not the same. Yeah, so we use like different markings. So it gets really annoying with segments because sometimes we do like 1 tick mark, 2 tick marks, 3, and then all of a sudden it's like, oh, now I got to get into 4 marks, 5 marks. So it can be kind of annoying. All right, is that the last thing on this section? No, we have one more thing. Oh, no, that's it. Okay, we'll stop there.